Hello, data scientists working on data analysis tasks. Today's lesson, we're going to cover the shape of the data distribution. In previous lesson to this, we have the size of the data distribution. Today, we're going to cover the shape of the distribution, which means if the data is normally distributed, if the data is symmetrical, or it has skewness. If the data is how far away from the mean, how far the spread is from the mean, one standard deviation away, which is 68%, two standard deviation away, which is 95%, and three standard deviation away, which is 99.7%. So that way we will measure the spread of the data distribution. For that, I have the data here collected from a local retail store where the salary of the retail cashiers and their corresponding experience levels have been recorded. And so are the names of the cashiers. The names are fictitious to make the data meaningful. Okay, so let's start doing this distribution analysis. So how are we going to do? Always start with importing. We're going to use pandas. Import pandas as PD. Import matplotlib.py plot as PLT. Import seaborn as SNS and plt.style just to show the background, nice background. plt.style.use ggplot. Okay, that will all be importation, nothing else. And once we have importation and we have the data, we can read now in the data is already here. We can read that p call df equals pd dot data frame. What we're going to do? Read data. Okay, just to check df dot head, just to check 5. Okay, shift enter. Okay, df is not defined, which means I have to run the kernel, restart the kernel, and it is running. Okay, here you can see now names, salary, and experience. Andrew, 27,000 salary, experience 6 months experience. Annie, 32,000 salary, experience 1.5 years salary. So this is the data frame. This is the data we have. This is the data. We will try to see how the distribution of data appears, whether it is bell curved or not. Okay, so let's begin that with the plot. Okay, we'll plot the scatter plot. df. Okay, let me just write scatter plot to see data distribution. To see data distribution, salary versus experience. Okay, so that is what we will do. Let me mark it down All right, shift enter. Okay, now let's draw the scatter plot. Okay, so SNS dot reg plot. See, that's why I got seaborn, because this is one liner usually. X axis equals experience. Okay, we will put X on x-axis, we'll put experience, and Y equals salary. All right, and the data equals df, and color equals lawn green. Let's put lawn green. Just trying to see if it comes green or not. Okay, now let's do here plt dot title. Let's give it title distribution of salary versus experience. Okay, all right, now plt.show. Okay, so we should be able to see the scatter plot. Shift enter. See, you can clearly see here the scatter plot with salary versus experience. From this, it is very straight. You can see higher the experience, higher the salary. See here, 3.5 years experience or more have the salary, highest salary, 38,000, 36,000, 36,000, 37,000, like that. And lower the experience, 6 months experience, 27,000. See, 1 year experience, 28,000, 29,000, like that. So the relationship is clear, although it is not very tight, because not all points are lying on the trend line. Only I can see only one point lying on the trend line. Okay, so nonetheless, it proves the point that scatter plot can show you the relationship, association of the variables. Higher the experience, higher the salary. So that is one insight from this. Now let's get real meaningful insight by calculating the z-score. Okay, so here let me just write the conclusion of that. Higher years of experience fetches higher salary levels. So that is the conclusion we will get from scatter plot. Let me just make it marked down so that it can be read. Shift enter. Okay, so that was the conclusion from there. Now let's calculate the z-score. df z-score, because z-score is the one which gives you the distribution of the data, right? It gives you empirical rule, mean 1 standard deviation away from the data, 1 standard deviation away from the mean will cover 68% of the area. 95% of percent will cover 2 standard deviation from the mean will cover 95%. Standard deviation away from the mean will cover 99.7%. That is the rule that z-score gives. Okay, so for that, z-score equals, let's do this. How are we going to calculate? What is the value of, what is the formula? Z-score is calculated by x minus x bar divided by standard deviation. So here df, what is, we calculating salary. df salary okay, df salary minus df salary x bar, we need to get the mean of the salary, dot mean. Okay, salary dot mean, df salary dot mean, okay, df salary dot mean. Let's make sure I am putting the in this so that there is no confusion. That mean divide by standard deviation. So that is going to be df salary dot std, standard deviation. Okay, so that is going to give z value of each row, which is not really meaningful. So just for the sake of showing you, I'm going to do that. Later we're going to calculate an overall z value, which will provide the meaningful z for calculating the standard deviations away from the mean. Okay, so let me just get rid of that. We don't need this table. Just that was to show you. Okay, now let's get ahead and calculate this empirical rule. df empirical rule. Okay, this is what we are going to calculate, equals pd dot cut. You see the cut method of pandas? That gives you the boundary of classes. Okay, so now within this boundary we're going to get df z-score dot abs. We need absolute value. Okay, not dealing with signs for z-score. Bins, let's get some bins. Let's specify some classes, class intervals type. Okay, bins equals 0, 1, 2, 3, float inf. Anything above 3 will be captured by this float inf. Okay, let's close that and let's set some labels. Equals let's some labels equals, we're going to do here within, let me make sure, within one standard deviation, okay, which is 68%, comma, within 2 standard deviation, which is 95%, comma, within 3 standard deviation, which is 99.7%, comma, beyond anything after that, beyond 3 standard deviation, 3 STD. Okay, beyond 3 STD. Let's close that. Okay, so we have bins and labels. Now right equals true. All right, so let's close that function. All right, so now bins equals invalid, forgot comma, where? Oh, forgot comma here. So to show the cumulative percentages, let's proceed this way. Let's write this. Rule counts equals df empirical rule empirical rule dot value counts. Okay, assuming normalization, normalize equals true times 100 to express in percentages. Okay, now let's print rule counts. Okay, print rule counts. Okay, let's shift enter. Empirical rule. Yeah, I forgot one code here. Code that. Now shift enter. You see, empirical rule. According to that, we have 68.75% of the observation of the data fall in the class of 1 standard deviation from mean, 25% fall in 2 standard deviation mean, which is almost 94%, and the rest 6% fall in 3 standard deviation. So that is, we can see that. Now let's calculate cumulative percentages. Okay, for that let's write cumulative percentages equals rule counts dot short index. Short index is a method that comes from that always gives you frequency. Okay, now let's print in the next line cumulative percentage. This is just the printing of the title. And print here we will show cumulative percentages. This will render that. Okay, shift enter. You see, now you see here cumulative percentage. Cumulative basically means adding up the categories. Okay, so 6875 plus 25 is 9375 plus 625 is 100. That is, we got the cumulative. So now what we need to do is we need to visualize to see it more clear, to see it clearly with plotting. We will visualize it. Okay, so for that let me write a column, visualize the empirical rule. Okay, make sure no errors. Empirical rule. So let me make it a markdown, shift enter. Okay, there is where we will visualize. Okay, so let's start with that. SNS.hist plot data equals df comma x equals salary. We're going to plot the salary. This is univariate. Histogram always does univariate. And stat equals density. We want like to show density curve. And KDE equals true. We would like the curve overlay. Okay, so that, and to get that effective, we need to calculate overall mean and standard deviation. So that we do with this. Mean salary equals df excess salary column dot mean method. Okay, similarly, standard deviation std salary equals df access the column dot std this. Okay, this will give us that. Now let's add vertical lines to show mean standard deviation. Okay, so here we be careful. PLT dot AXV line, vertical line, mean salary comma color equals red. I'm going to draw a red color picture. Line style equals dash dash to show the vertical mean line. It will be dash dash red line, comma label equals mean. Okay, so that is mean. Now we need those standard deviation, right? PLT dot AXV line, V line, mean salary plus standard deviation STD salary, comma color. So this color, one standard deviation away from mean, will be blue. Okay, we'll make that line blue, and line style will make that column. Okay, column. Label equals, here we're going to write mean 1 std, mean plus equals 1 std. Okay, mean plus equals 1 std. Remember, standard deviation on both sides. Okay, on the right side of the mean as well as left side of the mean, 1 std. Now we need, that is for the plus side, we need exact same thing for the next side. So for that, all we need to do here is, instead of plus, we will do minus. Okay, that gives you 1 standard deviation away from the mean on both sides in blue color. Okay, now 2 standard deviation. Let's get this down. We're going to cut both. So PLT that salary plus is going to be plus mean salary. Okay, make sure I am, yeah, plus 2 standard deviation. Okay, 2 times 2 standard deviation salary. Color is going to be, we're going to change the color. Let's make that color, 2 standard deviation color, green. Okay, and let's make line style also change. Let's change that as, say, dash dot. Let's make that kind of. Okay, 2 standard line label. Okay, mean plus equals 2 standard deviation, right? 2 standard deviation. Okay, that will be that. And second here, mean salary minus 2. Yes, 2 times standard salary. That color is going to be obviously same color, green, because both sides same color. And line style, that label we don't need because we already have there. Okay, so that. And now let's do, since we have all these colors, so that PLT.legend. Okay, now let's give the title as well, PLT.title. What title will be? Salary distribution with empirical rule markers. We have those markers. Remember, green line, red line, blue line. Markers. That is the title. Now, plt.show. Okay, so now if the typing, there are no typos, we should be able to see the plot. All right. Yeah, there is some error. Green is not a valid. GRENE. I have a typo. Yeah, here. I need to get rid of that. Okay. Now you see everything is perfect here. Okay, here I am going to explain this and then we are done for today. Salary with this mean is this line. You see, just under 34,000 is the mean. Mean plus equals 1 standard deviation is with blue. So here, this much. About 68-69% of the data, of the salary data that we have fall on this area, between this and this. Okay? And another 25% on top of that fall into this. So this is, out of 16 observations, almost all of them are captured by mean plus minus 2 standard deviation. Okay? 95% level are captured, all of them. And there is only a small portion of 2, like 27,000 salary guy, 1 observation that is below that, which is captured by 99.7%. From this, you can see that the distribution of the data shape, this is the shape, is normal. And in reality, in practical life, normality is assumed, especially when sample size is greater than or equal to 30. Any observation with sample size greater than or equal to 30, normality is assumed for z-score point of view to apply this empirical rule. So I hope you see in this clear illustration of the shape of the data that we created. We have from raw data to empirical rule application. So this is very important lesson. I hope you like this. This is clear and I have been able to explain and show you clearly as possible. So that's all for now. Thank you for watching. Stay tuned for more statistics using Python pandas. Thank you for now. Please subscribe to my channel. Thank you.